This is SpaceTime Series 27, Episode 104, for broadcast on the 28th of August 2024. Coming up on SpaceTime, the alien Big Wow signal finally solved. Well, maybe. The European Space Agency's cluster mission set to come to a fiery end over the South Pacific. And planet Earth hit by another powerful solar storm. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study may have finally narrowed down the likely source of the famous Big Wow signal. The signal was detected by the Ohio State University's Big Ear radio telescope in 1977 as part of the university's search for extraterrestrial intelligence SETI program, which ran from 1973 to 1995. It originated in the HD 164595 system, which is in the direction of the constellation Sagittarius. It lasted for the full 72-second window that the Big Ear was able to observe it. And it was so strong and unusual, astronomers had never seen anything like it before, they circled a printout of the signal data, writing "wow" with an exclamation mark next to it in the margins, and the name stuck. For years it was thought by many to be the most promising sign so far of a possible extraterrestrial intelligence trying to contact us, letting us know that we are not alone in the universe. That's because it was in a unique part of the electromagnetic spectrum's narrowband radio frequencies, right near the frequency for neutral hydrogen, a region long thought by scientists to be the most likely location for a cry in the dark from an extraterrestrial intelligence. But despite regular surveys of the signal's location, it's never been repeated, nor has anything like it been observed in any other part of the sky. Over the years, the WOW signal has become lore in the SETI world, and over time, it gradually faded into historic legend. Now, a report on the pre-press physics website archive.org suggests the signal was most likely caused by the sudden brightening of hydrogen emissions due to a strong transient radiation source, such as a magnetar flare, a soft gamma repeater, or possibly the first recorded astronomical maser flare event in the hydrogen line. All of these could have caused hydrogen clouds to brighten considerably for seconds or even minutes. The authors of the new study were even able to identify the hydrogen clouds responsible for the signal, but not the source of the radiation itself. That suggests it's far more distant than the clouds which produce the hydrogen signal. The new findings are based on archival data collected by the now defunct Arecibo radio telescope in Puerto Rico. The study's lead author, Abel Mendez from the University of Puerto Rico, says the Arecibo observations made between February and May 2020 have revealed similar narrowband signals near the hydrogen line, coming from multiple directions, but less intense than the original WOW signal. On the other hand, thanks to Arecibo's more advanced electronics compared to those available for the Big Ear, the signals are more sensitive, have better temporal resolution, and include polarization measurements. The authors say that these hydrogen flare events are rare, and they rely on precise conditions and spatial alignments between the source, the intervening hydrogen cloud, and of course the observer. It means what the Ohio researchers saw back in 1977 was a transient brightening of one of several neutral hydrogen clouds in the telescope's line of sight. Of course, this isn't the first time a possible solution to the Big Wow signal mystery has been hypothesized. For a long time, it was speculated to originate with a pulsar. Then in 2020, a report in Archive narrowed down the possible source for the signal to a distant sun-like star catalogued as 2-mass 1928-1982 minus 2640-123, which was detected in detailed observations undertaken by the European Space Agency's Gaia spacecraft. That star has a similar surface temperature, a similar radius, and also a similar luminosity to our Sun, making it and any surrounding planetary system a tantalizing target. The Gaia data provided far more detailed three-dimensional observations than astronomers had available to them when they previously hunted for a source for the signal. But even in 2020, there were some 66 other stars in the same catalogue, all identified as potential candidates. But this particular star appeared to be the most likely back then because it was by far the strongest candidate. This is SpaceTime. Still to come, the European Space Agency's cluster mission set to come to a fiery end over the South Pacific Ocean, and planet Earth hit by yet another powerful solar storm. All that and more still to come on SpaceTime. Next month, on September the 8th, the first of 4 satellites that make up the European Space Agency's cluster mission will re-enter Earth's atmosphere and burn up over the South Pacific Ocean. The spacecraft's fiery demise will mark the end of an historic mission which lasted 24 years, measuring space weather events and how they impact Earth's magnetic environment. This targeted re-entry will be the first of its kind. Launched back in the year 2000, the 4 cluster satellites have been studying perhaps one of the things that make Earth a unique habitable world where life can thrive, namely its powerful magnetic shield, the magnetosphere. Like an enormous umbrella, the magnetosphere protects life on Earth from most of the driving rain of particles that relentlessly stream out of the sun and the solar wind. But occasionally, powerful events such as solar flares and coronal mass ejections can push through this magnetic shield, sending bursts of energetic particles cascading down towards the Earth's surface. The most common result of these geomagnetic storms are the northern and southern lights, the aurora borealis and aurora australis, a kaleidoscopic spectacle that mesmerizes all who see them. But this storm of charged particles from the sun can also damage satellites, frying their onboard electrical circuits. It can disrupt radio communications and navigation systems, overload power grids on the ground, blacking out vast areas, increase the radiation dosage suffered by astronauts in space and even people in high-altitude aircraft. And it can shorten the life of satellites that do survive the initial electrical shock, by heating and expanding the Earth's atmosphere, causing additional atmospheric drag on those satellites, resulting in their need to use more fuel in order to avoid orbital decay. Until cluster came along, these space weather events all remained something of a bit of a mystery. We had a rough idea of what was going on, but no actual detailed numbers. And that's where cluster came in. For more than 2 decades, cluster showed how important the magnetosphere was in shielding the Earth from the solar wind and what happened when it was overwhelmed. Cluster watched the effects of solar storms to help science better understand and forecast space weather events. Cluster was initially launched on what was just meant to be a 2-year mission to study the Sun-Earth interaction. It was never designed to last this long. Because it was carrying out such impressive and world-changing science, ESA spacecraft operations decided to keep it going. But as the 4 satellites now gradually sink lower in their orbits, the end has finally come. Without intervention, the 4 cluster satellites will re-enter the Earth's atmosphere naturally in an unpredictable manner, potentially over densely populated areas. So by targeting the 4 satellites' re-entries, ESA will ensure that cluster's demise doesn't contribute to dangers on the ground or the rocketing amount of space junk currently orbiting around the Earth. The 4 cluster satellites are named Roomba for Cluster 1, Salsa for Cluster 2, Samba for Cluster 3, and Tango for Cluster 4. And it will be Salsa which is the first to take the plunge back into Earth's atmosphere. As with all planned satellite re-entries, mission managers are targeting a specific region over the southeastern Pacific Ocean known as Point Nemo, the furthest possible point in the ocean away from land and populated areas. Back in January, mission managers tweaked Salsa's orbit to make sure that on September the 8th, it experiences its final steep drop from an altitude of roughly 110 kilometres down to around 80 kilometres, at which point it'll start to experience the buffeting of Earth's atmosphere. This flight plan provides the greatest possible degree of control over where the spacecraft will be captured by the atmosphere and where it will begin to burn up. In fact, a targeted re-entry like this allows for so much predictability in the re-entry time and location that there's no need for any further manoeuvres. But despite being confident that no surviving fragments will fall anywhere near land, scientists really still have no idea about how spacecraft really behave as they pass through the lower layers of the atmosphere and burn up. And so ESA is considering observing Salsa's atmospheric re-entry using a specially equipped aircraft. Now, the 4 cluster satellites are all identical, so by watching them each enter the Earth's atmosphere on slightly different trajectories and under different weather conditions, scientists will have a unique opportunity to conduct valuable re-entry experiments studying the breakup of satellites. By seeing how Sulfur burns up, which parts survive, for how long and in what state, scientists will learn how to build zero-debris satellites. So far, the best guess scientists have is what survives to reach the surface, and that's almost always limited to stainless steel and titanium components. Following Sulfur's re-entry next month, the 3 remaining cluster satellites will enter caretaking mode. They'll not be undertaking any scientific measurements, but mission managers will be monitoring them to minimise the risk of collision with other satellites in Earth orbit. They'll adjust the orbit of Roomba in preparation for a similar targeted re-entry in November. They'll then manoeuvre Samba and Tango in November 2025, ready for Cluster's final orbital goodbye in August 2026. Now, the sort of science being carried out by the Cluster mission won't end. Late next year, ESA plans to launch its next mission to tackle Earth's magnetic environment, to be known as the Solar Wind Magnetosphere Ionosphere Link Explorer, or SMILE. It'll be a joint venture between ESA and the Chinese Academy of Sciences. SMILE will build upon Cluster's work, revealing even more about the complex and intriguing magnetic environment surrounding planet Earth. A case of literally standing on the shoulders of Cluster. This report from ESA TV.
After a drawn-out period of weak activity, our sun appears in recent months to have been jolted from its deep slumber, blasting tons of plasma into interplanetary space. The flares, constantly monitored by ESA's SOHO mission and other international spacecraft, emanate from sunspots with enormous magnetic filaments rising from the sun's surface. Having travelled 150 million kilometres, this mass of plasma buffets against our planet's magnetic field. It is this interaction that Cluster, Europe's space fleet to the magnetosphere, has been recording in 3D since 2000. Flying in close formation around our planet, the 4 identical spacecraft carry a suite of instruments to study the charged particles and Earth's electromagnetic fields in this region extending to around 50,000 kilometers above the atmosphere. Its observations have revealed a dramatic realm of invisible violence. In certain circumstances, magnetic whirlpools larger than the entire Earth bore into our magnetosphere, injecting venomous particles. As the sun's high-energy particles collide with molecules in the upper atmosphere, they lose energy, causing the molecules to glow and heat the atmosphere. The effects are well known, the shimmering curtains of red, green and blue light of the northern and southern auroras. The cluster quartet has been able to directly measure the acceleration of charged particles above the auroras. It has also observed black auroras, strange phenomena with dark, empty regions, anti-aurora, where electrons are sucked from the Earth's ionosphere. One of the major highlights of the mission has been the first look at the heart of a magnetic process called reconnection. This occurs when magnetic fields collide, releasing energy and allowing previously separated plasmas of gas to mix. It is the key mechanism that allows the solar wind to penetrate the Earth's magnetic shield. Understanding the magnetic reconnection is a major quest in physics. It is believed to be a fundamental process that drives powerful phenomena, the jets of radiation from black holes, or the powerful solar flares of our own solar system. Understanding what sparks magnetic reconnection will also help scientists on Earth trying to harness fusion reactors to produce electricity, but thwarted by uncontrollable reconnection events. Better understanding the interactions in the magnetosphere has introduced a valuable new discipline of predicting space weather. Storms generated by the solar outbursts can seriously hamper, even knock out electrical systems aboard satellites and damage power grids on Earth. Cluster has provided a continuous solar weather watch that now allows contingency measures to be taken. The satellite quartet's success is all the more resounding after the dramatic start of the mission. Years of work ended in the mangroves of French Guiana on the 4th of June 1996, when the first cluster spacecraft were lost in the catastrophic explosion of the first test launch of Ariane 5. But within 10 months the decision to try again was taken, and like a phoenix the satellites were rebuilt. 4 years later they were orbited in pairs by 2 Soyuz rockets, a tremendous achievement to relaunch the mission in such a short time. Rumba, samba, salsa and tango, as they are affectionately called, have been circling the Earth in formation ever since, conducting their own style of a complex orbital dance.
This is SpaceTime. Still to come, planet Earth hit by another powerful solar storm. And later in the science report, a new study has confirmed that eating higher levels of plant fats lowers your chances of developing heart disease and dying early. All that and more still to come on SpaceTime. Well, any of our listeners living at higher latitudes will know that the Earth's been pummeled by more violent solar storms erupting out of the sun, including several powerful X-class solar flares. And again, it's been spreading to lower latitudes. In fact, the US National Oceanographic and Atmospheric Administration, NOAA, says intense solar storms brought level 4 geomagnetic storm activity. That's on a scale of 5, and that's resulted in auroral activity seen as far south as Alabama and northern California. These solar storms are being triggered by powerful blasts of energy and plasma exploding out from the sun as solar flares and coronal mass ejections. When these particles hit the Earth's protective magnetic field, they cause the entire structure to vibrate. And when they're powerful enough, they can push through the magnetosphere shield, travelling along magnetic field lines down towards the magnetic north and south poles. And if you think the number of geomagnetic storms the Earth's facing are increasing, well, you're right. Back in May, the planet went through the most powerful geomagnetic storms recorded in 20 years, and they caused auroral activity to light up the night skies in the United States, Europe and Australia at much lower latitudes than usual. These events are expected to continue to increase both in strength and frequency as the Sun continues to move towards solar maximum, the climax of its 11-year solar cycle, at which point the Sun's magnetic polarity will reverse. Its magnetic north pole will become south and its south pole north. And that's expected to happen sometime between now and the end of next year. We'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. International researchers say people who have higher levels of plant fats in their diets also had lower chances of developing heart disease or dying early. A report in the Journal of the American Medical Association looked at data from over 400,000 people spanning 24 years, including nearly 190,000 deaths. They say diets rich in plant fats, especially those from grains and vegetable oils, were associated with a lower overall risk of heart problems and subsequently a lower risk of dying from heart-related issues. Inversely, the authors also found that those who had higher levels of animal-based fats, including those from dairy foods and eggs, had a higher risk of heart disease and a higher risk of dying from heart-related issues. A new study claims there may be a disproportionately higher risk of suicidal thoughts among people using the diabetes and weight loss drugs containing semaglutide. A report in the Journal of the American Medical Association analysed the World Health Organization database of suspected adverse drug reactions to compare the rate of suspected semaglutide-related suicidal thoughts with those of other similar drugs. The researchers say the reports of suicidal thoughts were slightly higher than expected for semaglutide, even when compared with other diabetes drugs. The researchers say they can't prove that using semaglutide causes this higher risk of suicidal thoughts, and it's highly unlikely that the risk outweighs the benefits of the drug for most people. A new study claims playing video games for less than 3 hours a day may actually have a positive effect on your mental well-being. The The findings, reported in the journal Nature Human Behavior, looked at data from almost 100,000 people, including more than 8,000 who were involved in a lottery to get one of 2 different gaming consoles. The survey collected details on whether participants had consoles, what their gaming preferences were, what their mental health was, what their degree of life satisfaction was, as well as their socio-demographic characteristics. They found that people who had a gaming console and played games on them had improved mental health over their peers. However, that was only for people who played for less than 3 hours. Those people who played for over 3 hours a day did see diminishing benefits. Interestingly, they also found that the simple act of owning a console was linked to improved life satisfaction, helping to reduce their psychological distress. Elon Musk's brain technology startup Neuralink says its implant, designed to allow paralyzed patients to use digital devices through thought alone, is working well in a second trialled patient that was implanted with the device last month. The company says the patient hasn't faced the same rejection issues suffered by the first patient back in January. Patient 1's implanted wires eventually retracted post-surgery, resulting in a sharp reduction in the electrode's ability to measure brain signals. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Okay, so Elon Musk has implanted, or his team has implanted, a second Neuralink into a human being, and he's now able to play Counter-Strike 2 with his mind. He's also designing 3D objects as well. So we really are getting into this whole idea of the force, in this case through technology, and I guess building the Cyberman or Cyberwoman. And this is a patient named Alex. Now, that's not me, but this is a procedure that went very smoothly, and Elon said in a post to X that if this all goes well, there will be hundreds of people with Neuralinks within a few years, maybe tens of thousands within 5 years, and millions within 10 years. And the progress is obviously amazing for somebody with a spinal cord injury, and obviously can control the computer cursor with his mind, and he was able to do that within minutes of connecting the linked device to his computer. And obviously, we're in a situation where the operation's only just recently happened, and the first recipient did lose some access to the Neuralink. There was a bit of rejection. The scientists were able to compensate for that and restore some of the connectivity. But it's a learning process, but it certainly does highlight the technology's potential for enhancing all manner of everyday activities. I mean, being able to control things with the power of your mind was once just science fiction, but this patient can control computer-aided design software. He had a mount for his Neuralink charger, a custom mount that was then 3D printed, and just incredible how even Elon Musk wants to create an optical product called blind sight, and this will enable people who've lost both eyes or have no sight to see. And he also said that if somebody has lost their arms or legs, they can actually attach an Optimus arm or leg during the Neuralink implant so that the commands from their brain would go to their robot arms or legs. So this is hearkening to Luke Skywalker losing his arm in a fight with Darth Vader.
I am your father.
These sorts of things are actually starting to be done for real. So it's a truly exciting time.
That's Alex Zaharov-Reutt from TechAdvice.life. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.